This is lesson 4-2 part 1. So we're starting off with lesson 4-2, which is titled Angles and Angle Bisectors. The learning targets in this lesson are to apply the angle addition postulate to find angle measures, and then to use the definition of angle bisector to find angle measures. So, you can measure angles with a protractor. The number of degrees in an angle is called its measures. We've talked about what the measure of an angle is in the previous chapter 1 actually. And then in the pre-geometry homework, if you had a protractor, I asked you to measure angles with a protractor. And so that's what we're going to try to do in P1 and P2. Okay, so P1 says to determine the measure of each angle. So what we're going to do is we're going to look at this protractor that we have right here. So let's first it wants us to find the measure of angle AOB. Okay, so what does that mean? We know what angle AOB, we know how to find that because of how we name angles. So AOB is right there. I look and see, so this the bottom of our angle is aligned with the bottom of the protractor, right? What we want to look at is the other side of the angle. So this ray OB right here, it lines up with, it crosses the protractor at either 130 degrees or 50 degrees. Since I know this is an acute angle, I know that it has to be the 50 degrees, not the 130 degrees. So measure of angle AOB is 50 degrees. B. Measure of angle BOC. Okay, so let's think about how we do this one. BOC goes from 50 degrees to 90 degrees. So to find the actual measure of the angle, we can take 90 degrees minus the 50 degrees to get that the measure of angle BOC is 40 degrees. The measure of angle AOC, you start at AOC, so this entire angle right here, this gives us, we can see that it's 90 degrees, right? We've got the hang of the protractor, now we've got measure of angle AOC is 90 degrees. Measure of angle EOD. EOD, that's going to give me, so look, I know it intersects at the 150 and then the 30 spot. It's an acute angle, so it has to be the 30 degrees. Measure of angle BOD. BOD. Well, that was bad. BOD right here. Okay. That was even worse. BOD right there. So B intersects at, say, 50. D intersects at 150. 150 minus 50 is 100 degrees. And that looks right because it looks like a slightly obtuse angle. So it's 100 degrees. So when you're doing this, if I'm looking at the bottom number on one side, and I have to look at the bottom number on the other side when I'm subtracting, okay? Subtracting angle measures. Lastly, we have BOE. So then, now we're at 0 right here. So what we're going to look at is the top number over here, because 0 is on the top. So that's going to give us a 130 degrees. Okay, so in class we used our protractors. If you have a protractor at home, go ahead and try this out. I'm not going to do P2 because I don't have a protractor on my computer. All right, so we're going to move on to angle addition postulate. Our angle addition postulate is very similar to the segment addition postulate, but except for the fact that we deal with angles rather than segments. So let's get started with what it is. Let's state it. It says if point P is in the interior of angle RST, then, so let's think what that means. Point P is in the interior of angle RST. I've got angle RST right here, and then I have point P, which is in the interior, which is just the inside, and then that means they have a ray that goes through them. And we have two. Note that we have two angles, this angle and this angle. Okay, so the angle addition postulate basically says we can add up two angles to get a larger angle. So let's write that in terms of the measures, in terms of an equation. So let me restate it. It says if point P is in the interior of angle RST, then the measure of angle RST is equal to the measure of angle RSP plus the measure of angle PST. So this angle plus that angle gives us the whole angle. All right. Notice it's very similar to like the second segment when we're adding two figures to get a larger figure. Okay, let's use the angle addition postulate in P3 and the given information to answer the following. So part A, if P is in the interior of angle XYZ, let me go ahead and draw this out. So I'm drawing all these out thinking that they're going to be an acute angle, you know, that angle XYZ is an acute angle. I don't know for sure it is, all right? It just helps me to see what this looks like, okay? Once you start doing it enough, you don't necessarily have to draw it out every time, but if it helps you, I would. And even if it doesn't help you, I would draw it out just to, so you for sure don't mess up, okay? All right, P is in the interior of angle XYZ. So we know that X will be a point right here. We have Y is the vertex, and then Z over here. And P is in the interior. All right, we know the measure of angle XYP is 25 degrees. And the measure of angle PYZ is 50 degrees. Find the measure of angle XYZ. So I know that the measure of angle XYZ is just equal to measure of angle XYP plus the measure of angle PYZ. Alright, so we know these two angles already, so this gives us, we plug in, so the measure of angle XYZ is just 25 degrees plus 50 degrees, which is 75 degrees. And that is our answer for the measure of angle XYZ. Okay, and of course, again, we'll be using algebra eventually to do this. So let's look at another similar one, but a little bit different. If M is in the interior of angle RTD, so RTD, M, RTM is 40 degrees, and then RTD, the entire thing, is 65 degrees. Okay, I'll do this. Put that in purple. Alright, so we want to find the measure of angle MTD. Alright, so measure of angle RTD is equal to the measure of angle RTM plus measure angle MTD. So RTD is 65 degrees, RTM is 40 degrees, and then we don't know the measure of angle MTD. This is just a variable that we keep for that. You could replace it with X if it helps you to solve the equation a bit easier. We'll subtract 40 from both sides, and we'll get 25 degrees is equal to the measure of angle MTD. And that's that. And now we have algebra, of course. So, draw our angle out again. E. So H is in the interior of EFG. Okay, the measure of angle EFH, 75 degrees. Measure of angle HFG, 10x degrees. And then the measure of angle EFG, the whole thing, is 20x minus 5 degrees. Okay, so measure angle. So I'm not going to write off the we have the segment addition postulate, we know it. So measure angle EFG is just 20x minus 5 is equal to the measure of angle EFH, which is 75 degrees, plus the measure of angle HFG, which is 10x. So doing some algebra, subtract 10x both sides, add 5 to both sides. We get 10x is equal to 80, divide both sides by 10, x is equal to 8. So we got our x already. Now I want to find the measure of angle HFG. And I know that has the expression for that was 10 times x, so 10 times 10, or 8, excuse me, is equal to 80 degrees. Okay, so in this case, this is actually going to be, this EFG is an obtuse angle, but I drew it as an acute angle because I didn't know at the time, you know. So, but worked out. I mean, it's alright. It's alright. It's just kind of a guide to help us know what to do, okay? Alright, next. Part D. Line DB and line EC intersect at point F. Alright, so let's see what this is. Line DB and EC. Okay, if the measure of angle BFC is 44 degrees, and the measure of angle AFB is equal to 61 degrees, find the measure of angle AFC, the measure of angle AFE, and the measure of angle EFD. Okay, first part, let's find the measure of angle AFC. AFC is just the large angle which contains the angle AFB and the angle BFC. We know what those two are, so we can say that the measure of angle AFC is just equal to that 44 degrees plus 61 degrees because of the angle addition postulate. So the AFC right here is just the addition of those two. So the measure of angle AFC is equal to 44 plus 61, which gives me a 105 degrees. Great. Now we want to find AFE. Okay, so we know that AFE is, we know that AFE and AFC both make up this straight line, right? They make a straight line together. So angle AFE supplementary to angle AFC. So we know their measures add up to 180. So I guess I'll write that the measure of angle AFE plus the measure of angle AFC is equal to 180 degrees. I know the measure of angle AFC, which is 105, so measure of angle AFE plus 105 is equal to 180. Subtract 105 from both sides, you get that the measure of angle AFE is just 75 degrees. All right, and then lastly, let's go ahead and draw this on here. The measure of angle EFD. So similarly, similarly, I know that this 180 degree straight line is made up of these three angles. So to find EFD, I can just subtract 180 from these two, because that's essentially what I did right here. I took 180 and subtracted 105 to get 75. Okay, so the measure of angle EFD is equal to 180 minus 75 minus 61. And then in my calculator, that gives me that the measure of angle EFD is equal to 44 degrees. And that's part D. Okay, two more in this part for our first video. We have P4 that says that if W is in the interior of angle TUV, okay, TUV, and then W. We know that TUW is 5x plus 3. WUV is 10x minus 5. And TUV is just 17x minus 6. Alright. So the whole thing right here, let's do, what color we want to do? Let's do bright red. Is equal to 17x minus 16. Find the x, the measure of angle TUW, measure of angle WUV, and TUV. Alrighty, so I've got, let's see, we know that this angle plus this angle equals the entire thing, so 5x plus 3 plus 10x minus 5 is equal to 17x minus 16. Okay, so this gives me 15x minus 2 is equal to 17x minus 16. Let's subtract 17x from both sides. I get negative 2x minus 2 equals to negative 16. Add 2 to both sides. Negative 2x is equal to negative 14. Divide both sides by negative 2, and we get a positive 7 for x. Okay. Plug x in to find TUW. Measure of angle TUW is equal to, so TUW is 5x plus 3, plug in 7 for x, we get 5 times 7 plus 3 is equal to 35 plus 3 is equal to 38 degrees. For the measure of angle TUW. Let's find TWUV now. Measure of angle WUV is equal to 10 times 7 minus 5. So that's equal to 70 minus 5. So the measure of angle WUV is equal to 65 degrees. And then lastly, we can find the measure of angle TUV by adding 65 and 38. So 65 plus 38 is equal to 103 degrees. You could have also just plugged in x into this 17x minus 16. Would have given you the same answer. Okay, if G is in the interior of angle DEF is a straight angle, so that means that the measure of angle DEF is 180 degrees. A measure of angle DEG is 23x minus 3, and GEF is 12x plus 8. Find x and the three angles. Okay. So, interior of angle DEF. Let's draw this one out. D, E, F. Okay, and it says that G is in the interior, so G is just some point right here, and E is the vertex. Okay, so we just have a linear pair basically. We know that the measure of angle DEG for sure is 23x minus 3, excuse me. And then GEF is 12x plus 8. Find x. So this angle plus this angle equals 180 degrees, doesn't it? We know what DEF is. It's just 180, so 180 is equal to 23x minus 3 plus 12x plus 8. Let's do the algebra now. We already 180 is equal to, let's see, 35 x plus 5. 8 minus 3 is 5. Subtract 5 from both sides. 175 is equal to 35x. So x is equal to 5. Alright, first I want to give you the measure angle DEF. We know that because it's a straight angle. That's 180. Okay. So plug in x to find DEG and GEF. Measure of angle DEG is equal to 23 times 5 minus 3. 23 times 5. Plug that all in our calculator, and we're going to get that the measure of angle DEG is equal to 112 degrees. So then the measure of angle GEF, I'm not even going to plug in. I know that it's 180 minus whatever DEG was, because DEF is 180. So then I've got 180 minus 112, and the measure of angle GEF is equal to 68 degrees. And that's the end of part 1 for 4-2. 4-2 part 2 will deal with angle bisectors.